Welcome back, everyone. I'm so glad you're joining us today because we're looking at something that honestly is an absolute game changer for how we approach our work. Today's explainer is hyper-focused on one monumental step in the learning journey, Day 5 code review, and specifically the SOLID principles. If you're looking to structure your code evaluations effectively, directly, and with zero fluff, well, you are exactly where you need to be. Let's just jump right in.
Day 5. Take a second to really let that sink in. In the context of our curriculum, Day 5 isn't just, another random square on the calendar. It is a critical threshold. It's the exact moment we shift gears, and looking critically at what we've built, through the meticulous lens of code review, takes absolute center stage.
So, Day 5 code review. We're stepping up our game here, moving way past catching simple typos and into a highly structured, analytical review process exactly as the text directs us to do. Okay, let's dive into this. The master key to our Day 5 review process is SOLID. You can kind of feel the weight of it, right? These letters are literally the foundational pillars of our entire evaluation strategy today. We're going to use this exact acronym as our ultimate standard to unpack what these 5 specific letters demand from us, because if you don't understand these, you simply can't evaluate architecture effectively. And here is the whole shebang revealed all at once. Single responsibility, open/closed, Liskov substitution, interface segregation, and dependency inversion. Now, these aren't just polite suggestions. They are the definitive core criteria of our review. Our source is incredibly direct here. We have to strictly, rigorously review our code for these exact 5 parameters. The crucial takeaway is that applying these principles isn't just some vague, hand-wavy theory. It's a strict 5-step procedural checklist. When you sit down for that review, you methodically go down this exact list. Single responsibility checked? Great. Move to step 2. It is a disciplined procedure to make absolutely sure nothing slips through the cracks. All right, let's drill down into each of these, starting with number 1, single responsibility. So what does that actually demand? Simply put, a class or module should have one and only one reason to change. It's the absolute bedrock of clean code. It should do one thing, and it should do it perfectly. If your code is acting like a giant Swiss Army knife, trying to juggle database connections, business logic, and the UI all at once, it's failing this first test. Because think about it, when a Swiss Army knife breaks, you've got to open up the whole mechanism to fix it, which puts everything else at risk. Isolating responsibilities protects your entire system from massive cascading failures. Let's move on to the second parameter, open/closed. In practice, this means your code should be open for extension, but completely closed for modification. You want to be able to add totally new functionality without tweaking the existing working code. It's like building a house. Imagine having to literally tear down your entire kitchen just to add a back porch. That would be ridiculous, right? Open/closed ensures you can plug new features right into your ecosystem without wrecking the core logic that already functions perfectly. Now for our third checkpoint. Liskov substitution. The name sounds incredibly complex, but the core idea is actually super elegant. Basically, if you swap a parent class for its child class, the program shouldn't break. The child has to do everything the parent does without any weird, surprising side effects. Like if your program is built to handle flying birds, throwing a penguin or ostrich class in there is going to crash your system. If it looks like a duck and quacks like a duck but suddenly needs batteries, well, you've got the wrong abstraction. It's all about ensuring your polymorphism actually works reliably instead of turning into a total minefield of errors. We arrive at the 4th pillar, interface segregation. This one sets a really strict boundary. No client should ever be forced to depend on methods it doesn't even use. It's like walking into a restaurant to order a burger, and the host makes you hold the employee handbook, the tax returns, and the entire supply chain manifest, along with the menu. It's just way too much. In code, instead of building one massive God interface that tries to do everything for everyone, you break it down into smaller, highly specific interfaces. It keeps the system incredibly lightweight and stops a tiny change from forcing massive recompilations across the entire code base. And finally, we wrap up the framework with principle number 5, dependency inversion.
High-level modules shouldn't depend on low-level modules. They both need to depend on abstractions. Think of it like plugging a lamp into a standard wall socket, rather than hardwiring the lamp directly into the electrical grid hidden inside your walls. That wall socket is the abstraction. Thanks to that brilliant little abstraction, you can easily unplug the lamp and swap in a radio or a toaster, without calling a licensed electrician to sledgehammer your drywall. When your high-level business logic relies on generic abstractions, your code becomes incredibly decoupled, flexible, and totally future-proof.
Identify SOLID violations. Because just memorizing the checklist isn't going to cut it. We're moving from pure theory into active, demanding practice. This perfectly illustrates the contrast we're dealing with. On the left, you have the ideal SOLID foundation, sturdy, reliable, and logical. But during your review, you have to confront the reality on the right. SOLID violations, a crumbling, chaotic, intertwined mess. We use these pure principles to ruthlessly hunt down those structural failures out in the wild. I really want to draw your absolute attention to this specific directive, pulled verbatim from our source. Practice, identify solid violations. It's totally unambiguous. On day 5, your theoretical knowledge of those 5 pillars must instantly translate into rigorous practice. You literally have to go hunting for where the code fails these standards. That is the true beating heart of the code review process we're exploring today. Which brings us to the ultimate question, the one you need to be asking yourself as you leave this explainer and sit down to review your own work. Can you identify solid violations? The principles give you the map, but actively finding those deviations, well, that's the real journey. Keep this 5-step checklist front and center in your mind. Next time you open a pull request, ask yourself, is this code truly solid, or is it just waiting to crumble? Thanks for hanging out and learning with me today, and I'll catch you on the next explainer.